ever kind of trip on something that's right there in front of you? Like, how did I not see that?
Happens to the best of us.
It's like our brains just completely blank out on, the whole depth perception thing.
Right.
And you're in for a treat because today we're diving deep into this whole world of depth perception with the visual cliff experiment.
Oh, classic.
Yeah. This experiment basically asks the question, like, are we born knowing how to see in 3D, or do we have to learn it along the way?
It's a big one, that nature versus nurture debate.
Yeah.
And this visual cliff thing, it gets right to the heart of it.
Yeah.
Especially when it comes to vision,
Totally. I remember once I totally misjudged the last few steps on a staircase and bam, just completely missed one. It's weird how something so fundamental to how we move around in the world can still trip us up. Literally. So I'm really curious to unpack this whole visual cliff experiment. What did the researchers actually do? Paint a picture for me, or should I say paint a cliff?
Okay, so picture this. You've got this table, but not your everyday coffee table. It's like this platform raised up high, maybe like 4 feet off the ground.
Okay, so already a little nerve-wracking.
Yeah, and here's the thing. The whole top of it, the entire surface, is made of this thick, clear glass.
Whoa, so you've got this see-through platform just kind of floating in midair. I'm a little nervous walking on that, let alone crawling around as a baby.
Oh, absolutely. But now, here's where it gets really clever. Underneath this glass platform, they put this surface with a bold black and white checkerboard pattern.
A bold choice, I like it.
Yeah, but here's the catch. On one side of the table, this pattern is right up against the glass, making it look, normal. This is the shallow side. But then, on the other side, they lowered the checkerboard pattern all the way down to the floor. So from above, it looks like a sheer drop, a deep side, even though that sturdy glass extends across the whole platform.
Okay, so it's like an optical illusion for babies, tricking their eyes into thinking there's a dangerous drop. But how do you test depth perception with, babies who can't exactly tell you what they're seeing?
Yeah, it's not you can just ask them, right?
Right.
So they had to come up with some pretty clever ways to figure out what was going on in those tiny little heads.
Clever how?
Right, so they tested 36 infants, all between 6 and 14 months old.
Got it.
And they placed each baby on this narrow board positioned right in the middle of the platform, separating that shallow side from the deep side we talked about.
Okay, I'm picturing it. What next?
This is where the moms come in. They had the mothers stand on either side of this visual cliff, you see.
So mom's the bait. I can see how that would be pretty motivating for a little one.
Exactly. The mothers would call to their infants, encouraging them to crawl towards them across the glass.
Okay, I have to know, did any of the babies just crawl right across the deep side? Did they even hesitate?
Well, that's the thing. When the mothers called to them from the shallow side, no problem. The infants crossed the glass, no hesitation.
Like it was just a regular floor.
Exactly, as if it were just a regular floor. But here's the twist. When the mothers called to them from across the deep side, totally different story.
They freaked out.
Not freaked out exactly, more like, they just wouldn't do it. Almost none of them, even with their moms cheering them on, would even attempt to cross that deep side.
Wow. It's like they knew somehow that it wasn't safe. So does that mean then that depth perception is something we're just born with?
Well, it's tempting to say that, right? I mean, it certainly seems like these babies had some kind of early awareness of depth.
Yeah.
But here's the thing. Even those 6-month-old babies, they already had 6 months of experience interacting with the world, right? They've been bumping into things, reaching for objects, figuring out how far away things are, even if it's just on a smaller scale.
So it's hard to completely separate, what's hardwired in their brains from what they've picked up just by living in the world for those first few months.
Exactly. And that's exactly why they didn't stop with just human babies.
This is where it gets really interesting.
Oh, absolutely.
Cue the baby animals.
They brought in a whole menagerie of baby animals.
We're talking baby chicks, turtles, rats, lambs, even baby goats. Okay, so what were the researchers trying to figure out by testing all of these different animals, these different species? What was the thinking there?
So by choosing animals that develop their motor skills at different rates, they could start to tease apart this whole nature versus nurture question, right?
Okay, I see where you're going with this.
Like, think about chicks and goats, for example. Those little guys, they're up and about, walking around almost immediately after they're born.
Yeah, no time to waste.
Exactly. They need to get a move on pretty quickly. And when they were put to the test on the visual cliff, both chicks and baby goats, they much preferred the shallow side. Almost immediately, too. Like they were born knowing to avoid that drop-off.
So are you saying those animals are born with a fear of heights? Which honestly makes sense when you think about it. If you're a small, wobbly creature, it's probably a pretty good thing to have that fear kind of built in. But what about the animals that aren't quite as quick on their feet after they're born? Like they can't just get up and go right away. How do they react?
Now, that is a great question, and it leads us to some really interesting findings with, well, rats, for example.
Okay, rats. Let's hear it.
Unlike the goats and chicks, the rats didn't seem to care one way or the other about the visual cliff.
Really? So they were totally cool just crawling across that clear surface, even with what looked like a big drop below.
That's so interesting that they would react so differently. I wonder why they would be so different from, say, the goats and chicks. Well, think about it. Remember how we were just talking about goats and chicks needing to be up and moving right away?
Yeah.
Rats, they develop a bit differently.
In what way?
Well, they're actually born blind. And so they rely more on their other senses to navigate the world, especially in those first few weeks, especially their whiskers.
So it's more about touch than sight, at least early on.
Exactly. Their world is less about vision and more about feeling their way through.
So you're saying those super sensitive whiskers are like their version of vision in those early days, at least?
Mm.
And even though those rats could see the cliff, it just didn't register as the same kind of threat. Not like it did for the goats and chicks who were relying on their vision from the get-go.
Precisely. It's almost as if depth perception might not be a one-size-fits-all kind of thing in the animal kingdom. You know, it might be more developed, more crucial for survival in those species that depend on keen eyesight, like your goats and chicks, for example, navigating rocky terrain, while other senses might be more important for other species.
This is reminding me of how some animals are said to even have a sixth sense, like echolocation. Are you saying that rats might be so reliant on their other senses that their vision and their depth perception just isn't as developed?
It's an intriguing thought, and it actually gets even more interesting when we look at another animal.
Kittens.
Go kittens. What about them?
So kittens, like rats, they also have whiskers. But they rely much more on their vision for hunting. And in the visual cliff experiment, they actually show better depth perception than the rats.
Okay, that actually makes a lot of sense when you think about it. A clumsy kitten wouldn't last very long if they were constantly misjudging jumps and distances, right?
Exactly. It really highlights how evolution fine-tunes an animal's senses, making certain senses sharper based on what's most essential for their survival.
Makes you wonder how turtles fit in, right? I mean, they're not exactly known for their speed or agility.
You'd think depth perception wouldn't be that crucial for them, especially compared to, say, a cat or a goat.
Exactly.
And yet, the visual cliff experiment throws us another curveball here. Okay, I'm on the edge of my seat. What happened with those turtles?
Well, while they didn't show as strong of a preference as the goats or chicks, the turtles did still demonstrate a slight preference for the shallow side. It wasn't as clear-cut, but it was definitely there.
So maybe it's less about whether they live on land or in the water and more about how their brains are wired for taking in visual information.
It really makes you think.
All right.
Okay, but then how do you explain all the times when, even we humans who supposedly have this amazing depth perception, we totally misjudge a distance?
Right.
I mean, I still trip on stairs sometimes, and I'm definitely not a baby goat anymore.
It's a great point, and it actually reveals some of the limitations of those original visual cliff experiments.
How so?
Well, remember how the youngest infants they tested were 6 months old? Later research, they actually decided to test even younger infants, some as young as 2 months old, to try and pinpoint exactly when this whole depth perception thing emerges. 2 months old? I can barely remember what I had for breakfast, let alone what it's like to be a 2-month-old baby. How can you even tell if a baby that young understands depth? They can barely, hold up their own heads.
Yeah, it gets a lot trickier. I mean, you can't really rely on those behavioral cues anymore, right? Like crawling towards mom or hesitating at a drop-off, not when you're dealing with infants this young. So they had to find other ways to measure their response.
So what do?
They got creative. They started tracking the infants' heart rates.
Their heart rate. So you're saying like a racing heart means they're scared of the deep side?
Well, it seems intuitive to think that a faster heart rate would mean, fear or stress. But here's where it gets interesting. What they actually found was that when these really young infants were placed on the deep side of the glass, their heart rates actually decreased slightly.
Wait, really? That seems so counterintuitive.
Yeah.
I would have thought a decrease in heart rate would mean they were just chill, like totally unfazed by the whole visual cliff. What's going on there?
It's wild, right? It turns out that in a situation like this, a decrease in heart rate can actually be a sign of interest, even curiosity, rather than fear.
Really?
Yeah. Think about when you're totally absorbed in something. A good book, a captivating movie. Your heart rate tends to slow down a little because your attention is totally engaged.
Okay, yeah, that's true. I never thought about it like that.
And that's what researchers think might be happening with these babies on the visual cliff. They're noticing the difference in depth. Their brains are trying to figure it out. And that focus, that trying to make sense of it all, it actually slows their heart rate down a bit.
So it's like their little brains are going, hold on a second. This is new. I need a minute to process this.
Yeah.
They're not scared, just intrigued.
Exactly. It suggests that these super young infants might be able to perceive depth on some level, even if it's just a subconscious thing. But that gut-wrenching fear of heights, that, oh no, I'm going to fall, feeling that seems to develop a little later.
Makes sense. It's not that we're born with a fear of heights, but that our brains are set up to learn about depth and the danger that can come with it as we start exploring the world.
Absolutely. And it's not just about our own experiences either.
Winning?
Well, remember those moms in the visual cliff experiment? Calling to their babies across the glass?
Yeah.
Well, later studies took that whole social element even further.
Oh, wow.
They found that 1-year-old infants that actually looked to their mothers for cues when they were unsure about a drop-off.
So it's like they're saying, Mom, what do you think? Should I go for it?
Exactly. And here's the thing. If the mother seems scared or unsure, the baby was way less likely to try and cross. But if mom gave them a reassuring smile or a little, you got this, then they were much more likely to try it.
Wow, that's so cool.
Oh.
It really shows how important those social cues are, especially early on. We're not just seeing the world, we're looking to others to help us figure it out.
Absolutely. And that actually brings us to the lasting impact of the visual cliff.
Oh.
Well, even though it was done way back in the 1960s, it's had this huge ripple effect on research. It's not just about understanding depth perception anymore. It's about how our genes, our experiences, our social interactions, how it all comes together.
It's amazing to think that an experiment from the 60s is still shaping research today.
I know, right?
So what kind of research is being done today because of the visual cliff experiment?
Well, for one thing, researchers have used versions of the visual cliff to study how toddlers use tools to solve problems.
Okay, I'm intrigued. Tell me more.
Well, they found that toddlers as young as 16 months old were more likely to cross a narrow, raised walkway if it had handrails, even if they'd never seen handrails before.
Whoa, that's some impressive problem solving for a toddler. Like they just instinctively knew those handrails would help them keep their balance.
It seems that way, right? Like their little brains are already wired for engineering and innovation.
That is wild. What else?
Perhaps the most exciting development is that the visual cliff has even made its way into virtual reality.
Whoa, really?
Yeah.
How does that work?
Researchers are using VR to create these virtual visual cliffs to help autistic children learn about depth and spatial awareness, all in a safe and controlled environment.
That is amazing. It's like this classic experiment has been totally brought into the 21st century. Well, this deep dive has definitely given me a whole new perspective on depth perception. Not just in babies and animals, but in myself too.
Me too.
It's a good reminder that even those things we take for granted, walking down the street, going up and down stairs, involve all this sensory information and experience, maybe even a little help from those around us. So to our listener, next time you misjudge a step or hesitate at the top of those stairs, take a moment to appreciate just how amazing your depth perception really is. It's a journey that started long before you took your first steps, and it continues to evolve with every step you take.